You know that feeling, right? When you're building an AI app and the chatbot just doesn't get it, or a recommendation system is completely off the mark? Well, a lot of the time, the problem isn't the AI model itself. It's the very foundation it's built on, the vector database. Today, we are diving into a skill that can honestly make or break your AI application, testing that vector database. Let's get into it. So why do our amazing AI tools sometimes go completely off the rails and give us these bizarre or just plain wrong answers? The reason often comes down to how well we test the very core of these systems. And today, we're going to map out exactly how to do that, so you can turn those unreliable results into trustworthy, amazing experiences. So what are we even talking about here? What is vector database testing? Well, it's a whole new ballgame compared to traditional testing. See, we're not looking for perfect one-to-one matches anymore. I think a great way to think about it is like you're testing a friend recommender. You don't want it to just find someone with the exact same name as your friend, right? No, you want it to find someone who is truly similar in their interests and personality. It's all about relevance and meaning, not just exact data. All right, here's the journey we're going on today. We'll start by understanding the core accuracy problem. Then we'll talk about building a solid foundation. After that, we'll get to the heart of it all, testing for meaning, before we really put it under pressure. And then we'll wrap it all up with the key takeaways that'll set you up for success. First things first, we have to make a pretty big mental shift here. This is all about moving from a world of absolute certainty to a world of similarity. Think about it like this. With a traditional database, you're asking a simple yes or no question. Is this the correct user ID? It's a world of true or false. It's black and white. But with a vector database, the question is way more nuanced. It's more like, how relevant is this document to what I'm asking? Here, the logic isn't about exact matches. It's about degrees of similarity, all those shades of gray. Okay, so before we can test for that complex, fuzzy idea of similarity, we've got to make sure the basic mechanics are solid. This brings us to testing the foundation. We have to ask, does the system just plain work? The best way to think about this first step is to picture a vending machine. Seriously, before you worry about whether the snack is any good, you just need to know one thing. If I press button B4, does the right snack actually drop down? It really is that simple. We're just checking if the database does what we told it to do. And here's exactly how you check that vending machine. First, you insert something specific, a piece of data you know. Then you verify you can get that exact piece back using its ID. Next, you test the filters. If you ask for everything with a certain tag, do you get the right stuff? And finally, you confirm that updates and deletions work just like they should. These are the basics, I know, but they are absolutely essential. Okay, with that foundation totally secure, we can now move to the most important part of our journey. This is really the heart of vector database testing, making sure it truly understands the meaning behind our data. Now, if there's one thing you remember from this whole explainer, please make it this. The quality of your AI application, pretty much all of it, comes down to the quality of your embeddings. So what are embeddings? They're just the way we turn our data, words, images, whatever, into numbers so the AI can understand their meaning and context. The source material is crystal clear. Embeddings drive over 80% of your quality, so you absolutely have to test them directly. So how in the world do you test for meaning? Well, think of it like giving your database a little similarity quiz. A classic example is this word analogy test. We check if the system understands relationships. Does it know that if you take the idea of king, subtract the idea of man, and add the idea of woman, you get something really close to queen? This proves it's not just matching words, it's actually getting the concepts behind them. And you know what? We can measure this with real numbers. A common benchmark you'll hear is a metric called recall at 10. Let's break that down. Recall is just a fancy way of saying, did we find the right answer? The at 10 part means we're checking if that right answer showed up anywhere in the top 10 results. So a goal of recall at 10 is greater than 90%, just means that for any search, we want the correct, most relevant result to be in those top 10 suggestions at least 90% of the time. Now that is a tangible goal. Okay, great. So our system is accurate, it understands meaning, but what happens when thousands of users start hammering it all at once? Well, it's time to put it under pressure. This is a perfect way to think about performance testing. It's just like load testing a bridge. You have to know its limits. How many cars can cross at the same time before traffic just slows to a crawl? Or even worse, the bridge fails. We have to ask these same tough questions of our database. So when you're load testing, you're always managing this critical trade-off. It's a balancing act. On one hand, you've got recall, that's your accuracy. Then there's latency, that's the speed of each query. And finally, you've got QPS, or queries per second, the total number of requests you can handle. And these things are often in tension with each other. Sometimes, to get more speed or handle more users, you might have to sacrifice a tiny bit of accuracy. The whole goal is to find that perfect balance for your specific application. We've journeyed through the problem, the foundation, the heart of testing, and the pressure test. So let's talk about the reward. What does success actually look like when you get all this right? Let me tell you a quick real-life story. There was a team and they were struggling. Their search results were just plain irrelevant. But instead of just guessing, they followed these exact steps. They tested their embeddings, they realized that that was the problem, and they switched to a better model. The result? A massive 40% boost in accuracy. I mean, huge. And the best part is, they automated those checks so that the problem could never come back. So let's boil this all down to the 3 crucial takeaways from our journey today. First, put accuracy first. Measure your recall and never forget that the quality of your embeddings is the single most important factor. Second, test performance under a realistic load and find that sweet spot between speed and volume. And third, automate everything. Build these tests right into your workflow so you can catch problems before your users ever see them. You know, following these steps isn't just about fixing bugs. It's about building trust. It's about building reliability. It's about creating AI applications that are genuinely helpful and intelligent. You now have the map to guide you. So the only question left is, what amazing things are you going to create?